Hi, my name is Dana McFarland, and I worked with Alyssa Redmills on this study while I was an undergraduate student at the University of Maryland. The title of the paper is Get Paid to Program, Evaluating an Employment-Aware After-School Program for High School Women of Color. So this presentation is broken down into the introduction, background, outreach program, evaluation, and summary and discussion portions. So our motivation. Within this last decade, we've seen a really big increase in growth of tech opportunities from cloud computing to AI. And while there are so many of these job opportunities, the field still remains very white and male. So we've also noticed a lot of diversity initiatives to increase the diversity in computing, such as Glitch Game Testers and GHSP, which is a Grace Hopper Scholars Program. So while a lot of these programs are after school based, a lot of them don't really take into account students' financial needs as well as the amount of time that they can dedicate to this program. And so Get Paid to Program exchanges funds for program participation. So there are four key principles that we used when we were creating Get Paid to Program. The first thing we looked at was moving from the traditional way that we see code, such as Java or Python, to visual programming languages such as Scratch or Alice. And so studies have shown that visual programming languages are great ways to introduce students to computational thinking, which is why Get Paid to Program first introduced students to Scratch. The other item that we looked at, topic that we looked at, was role models. And we found that students who had same gender and same race role models ended up thinking more about their future and overall had better outcomes than those without. And so with this information, we employed 2 undergraduate women of color to teach the course. We also looked at group collaboration, and studies have found that students who did group collaboration fared better than students who worked individually. And so we incorporated a lot of group collaboration into our curriculum. And we also included industry visits, which are great ways to introduce students to computing in context, as well as see the workplace in action, which makes the workplace more attractive to the students. So Get Paid to Program itself is a 10-week hands-on program that introduces high school women of color to computing. And it was taught in both fall 2017 and spring 2018. And so there are 3 significant time pieces here. So the first 3 weeks, students learn Scratch. Then from week 4 to 9, they do basic web development, such as HTML, CSS, and JavaScript. And each class is broken down into an hour-long sessions where the first 15 minutes is typically review. The next 45 minutes are them working hands-on to complete a project based on information that they learned within the first 15 minutes. And then the final week is a industry visit where in the first session, students ended up visiting Facebook. And then in the second session, students visited Lockheed Martin, where they were able to tour the facilities. And something important to note is that both food and transportation was provided for the students. And so there are 3 major curriculum pieces that we used. There was curriculum in a box, which is a multi-modular approach that included videos, interactive exercises, shorter lectures that specifically taught students about Scratch and web development. There was also W3 tools for those smaller interactive components. And there was also custom teaching materials created by the undergraduate students. And so these were specifically designed for beginners, and it was mainly used to reiterate the concepts learned for HTML, CSS, and JavaScript. Evaluating program efficacy. So for methodology, we used posters and flyers around the high school to actually recruit the students. And we also had pre and post program questionnaires to determine students' the efficacy of the program in the form of questionnaires, as mentioned. We also used descriptive and statistical analysis of the participants' questionnaires for our data analysis. And so we did notice that we had 2 major limitations. One, it was concentrated on a single school, so we weren't sure how applicable the program would transfer over to other schools. However, we did run this program twice with similar results. We also noted that it is not fully possible. It's possible that our questionnaire didn't fully measure students' attitudes. However, we did use pre-validated measures. And so overall, with both of these limitations, there are validity threats that remain. And so we implemented our program in a majority minority high school where 36% of the students were on free and reduced lunch. As mentioned, we did have all women, so we had about 30 participants with a wide range of skills as well as grades. So 5 were freshmen, 13 were sophomores, 8 were juniors, and 4 were seniors. And additionally, 21 out of the 30 students reported that they've never programmed before. And we also had 18 who mentioned that they never worked with a scientist or engineer. So one outcome that we saw was a significant improvement in computing self-efficacy after participation. And so we used Mann-Whitney U-test to compare pre and post survey means on various questions. And so we specifically asked students to rate how much they agree or disagree with statements such as, I like computer science, I'm good at computer science. So this just shows the self-efficacy scores pre and post intervention. We also noticed refinement in career interest in computer science, programming, and engineering. So while there's no statistically significant change in career interest, we noticed that participants were more interested in computing-related fields, or refined interests, not necessarily in the broader STEM careers. So figures 2B through 2D show the interest in computer science, engineering, and computer programming. And then figures 2E and 2F show that results were similar both pre and post survey. So the qualitative insights provided some confirmation for the quantitative results that we previously found. So we saw students who said, I never really considered programming until get paid to program, or they said, I know that they know that they want to pursue a career in software engineering or something of the like. We also had 1/3 of the students mention that funding actually either helped them stay in the program or encourage them to join. And then we also had students who mentioned that they really appreciated the role models as well as having a more freedom on what project they were working on. So overall, we found that Get Paid to Program had a positive effect on the self-efficacy of students and narrowed down their possible career paths. And so while it didn't fully seem to impact their interest in math or science, it did raise the interesting point that the computing and engineering fields may not be fully embraced when discussing the broad STEM as a whole. And so future work may wish to examine precisely which portions of the Get Paid to Program approach were most critical to positive understanding. And then overall, again, our study suggested that the pipeline programs remain a best practice for supporting equity and inclusion in computing, as well as these programs should tailor to computing and be computing focused versus trying to pertain to the general STEM focus. Thank you.